In this podcast episode, theoretical physicist and cosmologist Janna Levin joins Lex to discuss a wide array of fascinating topics, including black holes, wormholes, the nature of consciousness, and the mysteries of the universe. Levin, known for her work on black holes and gravitational waves, brings a unique perspective to these subjects, blending scientific rigor with a poetic appreciation for the cosmos. Black holes are one of the most enigmatic phenomena in the universe, and Levin begins by explaining how they curve space and time. According to her, black holes create a gravitational well that affects everything around them, causing objects to follow the curves in space. This curvature is not static. As black holes move, the curves in space follow them, creating waves in the fabric of spacetime. Levin describes a scenario where two black holes orbit each other, generating ripples in spacetime that can eventually lead to their merger. This process emits gravitational waves, which are not light but rather distortions in the shape of space itself. Levin emphasizes that the merging of black holes is not an infinite process, despite the time dilation effects caused by their immense mass. The simulations of these mergers reveal a dynamic dance where two event horizons bobble and eventually combine into a larger black hole. This new black hole then radiates away imperfections, settling into a quiescent state. The mass of the final black hole is less than the sum of the original two, as energy is radiated away in the form of gravitational waves. This phenomenon highlights the intricate relationship between mass, energy, and the structure of spacetime. The conversation shifts to gravitational waves, a groundbreaking discovery that has revolutionized our understanding of the universe. Levin explains that gravitational waves are produced when massive objects, like black holes, move and create ripples in spacetime. These waves travel at the speed of light and can be detected by instruments like LIGO, which was designed to measure the incredibly subtle distortions caused by these waves. The sensitivity of LIGO is astounding. It can detect changes smaller than a fraction of the diameter of a proton over a distance of 4 kilometers. Levin recounts the excitement surrounding the first detection of gravitational waves in 2015, which confirmed a prediction made by Einstein's general relativity. The event marked a significant milestone in physics, as it provided a new way to observe the universe. Gravitational waves allow scientists to study cosmic events that were previously invisible, such as the collisions of black holes and neutron stars. Levin highlights the poetic nature of this discovery, as it connects the abstract mathematics of relativity with tangible observations of the universe. One of the most intriguing topics discussed is the black hole information paradox, which challenges our understanding of quantum mechanics and general relativity. Levin explains that when particles fall into a black hole, they seem to disappear, leading to the question of whether information is lost forever. This paradox has sparked intense debate among physicists, as it suggests a fundamental conflict between the principles of quantum mechanics, which assert that information cannot be destroyed, and the behavior of black holes. Levin describes various proposed resolutions to the paradox, including the idea that information is somehow encoded in the radiation emitted by black holes. This concept, known as Hawking radiation, suggests that black holes can emit particles, allowing some information to escape. However, the challenge remains in understanding how this information is preserved and whether it can be retrieved. Levin emphasizes that the resolution of this paradox is crucial for developing a unified theory of quantum gravity, which would reconcile the principles of quantum mechanics with the curvature of spacetime described by general relativity. The discussion then turns to wormholes, theoretical passages through spacetime that could connect distant regions of the universe. Levin explains that wormholes are often depicted as shortcuts, allowing for faster-than-light travel between 2 points. However, the reality of wormholes is much more complex. They require exotic matter with negative energy to stabilize them, a concept that remains largely theoretical. Levin notes that while wormholes are fascinating constructs, their practical realization poses significant challenges. Levin also discusses the relationship between wormholes and black holes, suggesting that they may be connected in ways we do not yet fully understand. The idea of traversable wormholes raises questions about the nature of spacetime and the potential for interstellar travel. Levin highlights that while wormholes are a captivating concept, they remain speculative and require further exploration within the framework of modern physics. As the conversation progresses, Levin and Fridman delve into the search for extraterrestrial life. Levin expresses her belief that the universe is teeming with possibilities for life, given the vast number of planets and stars. She emphasizes that the sheer scale of the universe makes it improbable that Earth is the only planet with life. However, the question remains, why have we not yet encountered evidence of alien civilizations? Levin suggests that the absence of contact with extraterrestrial life could be attributed to various factors, including the vast distances between stars and the limitations of our current technology. She also raises the possibility that advanced civilizations may exist in forms we cannot yet comprehend, challenging our understanding of what life can be. The conversation highlights the importance of remaining open-minded and imaginative when considering the potential for life beyond Earth. The topic of consciousness emerges as a central theme in Levin's discussion. She reflects on the nature of consciousness and its relationship to the universe, pondering whether consciousness is a fundamental aspect of reality or merely an emergent property of complex systems. Levin acknowledges that consciousness remains one of the greatest mysteries in science, with many unanswered questions about its origins and implications. Levin's exploration of consciousness leads to a broader discussion about the interconnectedness of all things in the universe. She suggests that understanding consciousness may provide insights into the nature of reality itself, bridging the gap between science and philosophy. The conversation emphasizes the need for interdisciplinary approaches to tackle the profound questions surrounding consciousness and its place in the cosmos. The concept of the multiverse is another intriguing subject that Levin addresses. She explains that the multiverse theory posits the existence of multiple universes, each with its own set of physical laws and constants. This idea challenges the traditional notion of a single, unified universe and opens up new possibilities for understanding the nature of reality. Levin discusses the implications of the multiverse theory for our understanding of existence. If multiple universes exist, it raises questions about the uniqueness of our own universe and the potential for different forms of life and consciousness to emerge in other realities. The multiverse theory invites speculation about the nature of time, space, and the fundamental laws that govern the cosmos. As the conversation draws to a close, Levin reflects on the future of physics and the challenges that lie ahead. She emphasizes the importance of curiosity and exploration in driving scientific progress. Levin believes that the pursuit of knowledge is a fundamental aspect of the human experience, and she encourages future generations of scientists to remain open to new ideas and possibilities. Levin's insights into the future of physics highlight the interconnectedness of various fields of study, from cosmology to consciousness. She expresses hope that continued exploration and collaboration will lead to breakthroughs that deepen our understanding of the universe and our place within it. The conversation serves as a reminder of the beauty and complexity of the cosmos, inspiring listeners to embrace the mysteries that lie ahead. Throughout the podcast, Levin emphasizes the intersection of art and science, highlighting the importance of creativity in scientific inquiry. She believes that artistic expression can enhance our understanding of complex concepts and foster a deeper appreciation for the beauty of the universe. Levin's work at Pioneer Works exemplifies this philosophy as she seeks to bridge the gap between scientific exploration and artistic expression. Levin's perspective on the relationship between art and science encourages a holistic approach to understanding the world. By embracing creativity and imagination, scientists can unlock new avenues of inquiry and inspire others to engage with the wonders of the universe. The conversation underscores the value of interdisciplinary collaboration in fostering innovation and discovery.